Hi all, this is Alan with Bothell STEM Coach, and today we're looking at the 2019 AP Statistics Free Response question number 4. As usual, I'll have, if I made any mistakes in the video, I'll put corrections in the description below, as well as links to my PDF solutions are also in the description below. So tumbleweed, commonly found in the western U.S., is dried structure of certain plants that are blown by the wind. Kochia, type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. Scientists are concerned that kochia plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected kochia plants were resistant to glyphosate. In 2017, 38% of 52 randomly selected plants were resistant. Did the data provide convincing statistical evidence? So we have two proportion samples, and we're comparing them. So this is a two-sample proportion because it's a percentage. And in a two-sample proportion, we're going to set up our null hypothesis is that P1 is equal to P2. And the alternate is that P1, well, let's designate. P1 will be, we'll say 2017 numbers, and P2 is the 2014 numbers. And so P1 hat in particular is 0.385. P2 hat is equal to 0.197, and N1 is equal to 52, and N2 is 61. Okay, and make sure I did that right in the solutions. Yes, I did that right. Okay, cool. So this one, I want to know my alternate, as I think they're becoming more resistant. So I'm thinking this proportion sample is larger than this one. So I'm trying to see, like, are they more resistant, in fact, or a higher proportion are resistant. So what are our statistics? We're going to use a Z statistic in here because for proportion testing, you actually always know the population standard deviation because it's a binomial distribution. So we do P1 hat minus P2 hat over the standard error. And the standard error for two proportions is P1 hat 1 minus P1. Oh, no, it's not P1 hat. It's P1 without the hat. Oh, actually, it is P1 hat because I don't have the population. And if you calculate this Z statistic, I did use my calculator on this before. I got it. This is 2.22. If I plug in these numbers all into here. Okay, so, and then you can use a Z table, but I'll go ahead and show you the calculator process for this. So let me pull up the calculator. All right. And so you could do a hypothesis testing. The only thing about hypothesis testing is I think, the prop testing is they actually want you to do X1, which is the number of samples. So 0.385 times 52 is the number that were resistant. So that was 20. And then for X2, we're doing 61 times 0.197, which is 12. Okay. And so if I do, let's see, stat test, two proportion Z test, X1 is 20. N1 is 52. X2 is 12. N2 is 61. And we want to know that it is greater. So you see the Z value, 2.22, is there. 2.22 is about 2.221, I guess, if you want to do it one more decimal place. And my P value, I got 0.136, right? Which is this one right here. Or I guess, I don't know if you can see that. And so this is less than, okay, actually it's 0.0136. Sorry about that. That's less than 0.05, right? This is 0.01, 0.05 is smaller. So yes, so basically we reject H naught. And yes, there's sufficient evidence that the proportion has changed and increased, and so they've gotten more resistant to glyphosate. Okay, So hope you found that helpful. Let me know if you noticed if I did anything wrong in that setup. And I guess one thing I probably should have done, which I didn't write in the notes, is double check that we can use the hypothesis testing. They may actually check for conditional. So you want to do like n1 p1 hat is greater than 10, n1 1 minus p1 hat is greater than 10. You know, you do all these checks, right? P2 n2 p2 is greater than 10. And these will all be, because these numbers are pretty big. So like 61 times 0.2 is like 12 or so, and 0.385 times 52, I think we said was already, well, you already know because this is 12. Yeah, so it met the conditions for doing the distribution, but it's good to like double check those. 1 minus p2 are greater than 10. Okay, and they are also two independent samples. They were randomly selected, and they were randomly selected from each other, so they're independent samples. So those are the conditions for checking for doing the hypothesis test there. So anyway, but yeah, if you notice I did anything wrong or you have any questions, let me know in the comments below. Thanks. I'll see you in the next video.